Welcome to tutorial number 12 for the course Problem Solving through Programming in C. This is a SWAM course floated by Professor Anupam Basu from Department of CSE IIT Kharagpur, and I am Siddhant, and I'm one of the 4 TAs who are in charge of all these tutorial sessions, which will help you out in solving problems in the assignment as well as in the final exam. Okay, so in week 12, we covered the lectures. The lectures covered structures using type def, pointers in structures, and some dynamic memory allocation and so on. Okay, so we'll be looking at some sample questions on those topics. So let us start. So first I have a few questions on structures for you. So the first question is we have a structure. We have defined it as struct student, and it contains basically a character pointer called name. And then in int main, we have defined two different structures of type struct student, and we have written s1.name, that is the character pointer that we have. S1.name is equal to stu, and we have done a equality kind of thing, not equality, we have done an assignment thing where we are assigning structure s2 as structure s1. So and we are trying to print what will be s1.name and s2.name. Both of them are strings. As you can see from here, it is stu and it has been defined as a string, or you can define a string as a character pointer as well. So what exactly will be the output from this particular printf statement? So I have right. So I have s1 and s2. These are two structures, and the members are s1.name and s2.name respectively. And I'm saving s1.name as stu. This is the string that I'm saving into s1.name, and I have done s2 equal to s1. So this is a legitimate operation for a structure. This is a correct way. There is no error here from the syntax perspective. So what this exactly does is all the members, the value of all the members of s1 will be copied to s2. Are copied to s2. So this is what happens here. So all the individual members, because s1 and s2 are both structures of the same category, that is struct student. So they have the same members, which is name. That is the common. That is the same member that both of the structures have. That is s1 and s2 have. So when we do this kind of assignment operation, what basically happens is the value of all the members of S1 will be copied to the respective members of S2. So here when we print this, after doing this operation, when we do S2 is equal to S1, S1.name, whatever value it had, it gets copied to S2.name. So S2.name is also STU now. Now when we print this as a string, we'll have STU and STU being printed. I hope that is clear. Okay, so we can move on to the next question then. So this is another question on structures that we have. So here we have defined a structure inside the main function. Rather than defining it globally, we have defined it inside the main function, and we are saying struct entity in braces. The members are int x is equal to 2 and char ins blank braces is equal to iat. Now this is the structure that we have defined, and we are defining this is the structure prototype, rather you can say, and we have defined a structure. We have we are declaring a structure S1 which is of type struct entity, and then we are trying to print s1.ins and s1.x. So what exactly will be the output here from this print statements? Okay. You can write your answers in the chat box, or you can also um, unmute and speak. Either way is fine. Why is that? Can you justify that? Okay. So, mhm. Right, right. So this state, so this statement is fine, but there is some issue with this statement, especially pertaining to this percentage %d, because this is a character array, as he correctly stated. This is a character array, so we cannot use a percentage %d. Instead, we have to use a percentage %s if we want to print s1.ins. So in this case, it will give us a compilation error. Is that fine? So there was an issue uh, with the format specifier rather. So instead of this, we just needed to use a percentage %s because this is a string, right? This is a string. So we need to use percentage %s while printing this. So we would have got the right answer in that case. Okay. Okay. So I have a few more questions on the same, and well, right. So we have this struct xyz. It has a member which is int a, and we have a variable that we have defining of type struct xyz, and we have given it as we have this is a way to initialize. This is how we can initialize a structure variable, right? So in curly braces, we just give the variable. So if we have say int a, then say we have char star s. Okay. So in that case, in that case, say I had this xyz struct xyz. I wanted a variable one. I could have written it like this. So the order of the definition of the members actually matters while we are initializing a structure variable. I could have written 54 comma IIT. So this would have been a way to define a structure. Okay. Similarly, if I want to define a array of this structure, I could have done it in this way: 54 comma IIT comma 64 comma Madras. Okay. So this would define a structure which is containing two elements. The first is 54 comma IIT. In the particular member, this is A, this is S, and the next element of the array would be 64 and Madras in respective A and S. Okay, so that is how you would define, you would initialize a structure variable. So here we have initialized the structure variable obj1, and we have written 11 in the curly braces. That means the member variable, that is A. So obj1 dot A is actually 11. Okay. Now similarly, we have again defined another structure object of type struct xyz, and we have said obj2 is equal to obj1, right? That means, like we saw in the previous case, obj2 dot a will become obj1 dot a, that is obj2 dot a will be 11. Okay. Now we are printing percentage %d obj2 dot a, and then we are setting obj2 dot a to 101, and we are printing again. So what should be the answer for this? So this for sure should be 1 1, that is for sure, because I already explained how it will be 1 1. Now we have changed the value of obj2.a to 101. So what will be, uh, what should you see here as the output? So thing is, if you change the value of obj2 dot a to 101, that still does not change the value of obj1 dot a, right? Because that was the assignment operation done earlier. That was for that step. That step is already executed and over. There is no implicit connection between obj1 and obj2. So when you change the value of the member of obj2, it will not affect any members of obj1. So here obj1.a is still 11, while obj2.a is now 101 because we set it to 101. So what will be printed here? So first 11 was printed, then again we'll have 11, then 101. So we have 5 ones, 10. So I think option B should be the answer. So is that clear to everyone? Okay, fine. So let's move on to the next question. So this question actually, I will leave it for the end because there is something I need to explain here, which is called structure padding, and this why exactly it is done and so forth. We'll discuss that at the end because that will come into the picture here. So probably I'll explain that first, and then maybe you will be able to answer this question yourself. Okay, so I'll move on to the next question. I'll come back to this at the end. Okay, so far any questions? No? Okay, fine. So now we have a few miscellaneous questions. These are probably pretty easy for you by now. You have already been through uh, 12 weeks of lectures on C, so by now I'm pretty sure you'll be able to answer this question well. Okay, so we have here a function which is called fun, and it takes a array as a parameter, and it returns some int value. That is what it's written. And what we do here is we increase ARR by 1 and we print percentage %d ARR of 0. Okay, and now we have a int main function which has no parameters as input, and we define a array ARR which is containing, or rather initialize it, is that it's containing 3 elements, 5, 10 and 15. Now we call the function called fun by passing this ARR variable from here, and after it is passed we print ARR of 0 and ARR of 1. So what exactly do you think should be the output from this code? Anyone? Just try to think about what exactly happens when you do this ARR plus 1 operation. Okay. Okay, so can you explain that, why it is option C? Mm, 5 and 10 come later, and then the function value. I couldn't get your explanation actually. So what happens basically when this fun of ARR is called in this particular step? What happens in this function? Can you just tell me that? Okay, okay, right. So what happens here? You're correct. So what happens here when we call this fun of ARR? This ARR, I probably explained in a previous lecture. When you say just ARR, this is a pointer. Okay, let me just write it down. So ARR of 3 is 5, 10 and 15. So this is our array. So when you say ARR, it is basically, it is a pointer to the first element of the array. Okay, that is 5, right? So it's a pointer. Now when we do this pointer plus 1, that means it just initially it is pointing at this position, that is 5. It just moves to 10 when you do ARR plus 1. So when you do ARR is equal to ARR plus 1, so it just moves from 5 to 10. Now it points to 10. So if you write ARR of 0 now, it will give you 10 instead of 5, because the pointer is now pointing, like the pointer ARR is pointing to the second element rather than the first element. We incremented it by 1. So ARR of 0 is now 10. So here when you do this when you call this function, ARR is incremented by 1. This percentage d, this particular printf statement will give you a value of 10 as the output. Okay, now returning back to, so it does not return anything, as you can see. So it is, even though it is an int function, so there might be a warning thrown that you need to return something. Okay, but we'll just ignore that for now. So here we are not taking anything. Okay, here we are not taking anything at all. Okay, so we can just change it to void type then, because this function does not really return anything to the main function as well. Okay, so after that, the print statement that we have, it refers to ARR of 0. So this ARR function and this ARR variable and this ARR variable are actually different. So this is kind of a formal parameter and this is the actual parameter, right? So this formal, this is it. It is a different variable that we are talking about. So even though this ARR variable here has changed its position by 1, that is the index is changed from 5 to 10, the same is not true for this ARR variable which is in the main function. Okay, this ARR variable still points to 5 as its it still points to 5, which is the first element of the array. So ARR of 0, when you say it in the main function, it still means 5, and ARR of 1, when you say it in the main function, it still means 10. So here our answer will be C. So we had 10 from the fun function and 5 and 10 being printed from the main function. So is that clear? Okay. Okay, the next question is pretty straightforward. So we have a pointer and an integer variable a, which is 10, and we are doing pointer is equal to an ampersand of 10. This ampersand basically is a referencing operator, which means it refers to, say we write p is equal to an a, that means this pointer p will save the address of variable a. Okay, that's what the operation is being carried out here. So we write ampersand 10 and we print percentage d star p, which is that means we are printing the value of, we want to print the value that is stored in this location which is pointed by the pointer p. So what will be the output of this particular code? Okay, so the output will be b, or okay, so why is that? Right, right. So not exactly that, but okay, yeah, it's true. So we need, this needs to be a variable. Okay, whenever we write this ampersand, so ampersand will always work on a operand. So it is a unary operator which will work on an operand which should be a variable, because variable means you have a memory location which this pointer can have the address of. So it needs to be a memory location, right? Otherwise what will be the pointer pointing to? The pointer needs to point to a memory location, and only if it's a variable, only then it will have a memory location in the RAM somewhere, and the pointer p can point to that particular memory location. If it's just a numeric value, then it does not have a memory location allocated to it yet. So that is why it will throw a compilation error here. If you had written p is equal to and of a, only then you would have got here an answer of 10 in the print statement. Uh, but we have written and of 10, that is ampersand of 10, that means it will throw a compilation error because there is no memory location allocated to this numeric constant basically. Okay, so I hope that is pretty straightforward. Okay, so we'll see one question on dynamic memory allocation. So dynamic memory allocation, basically till now we had been seeing where we are defining int, say a is equal to 10 or arr of something is equal to 5, 10, 15. So all of this were static memory allocation. So here our memory allocation occurred whenever we compiled the code. So it was compile time memory allocation. Okay, but in dynamic memory allocation we will allocate the memory at runtime. Okay, so we'll allocate the memory at runtime when we are using dynamic memory allocation. So why is that helpful to us? Because it is helpful because we have a control over the amount of space that is being used by the code, among many other advantages and also some disadvantages. We have more control over the amount of space that is being required by a code during execution. So in many times you can see that you have variables which have outlived their purpose, but they are still there. They are not, the space allocated to them has not been freed. But in dynamic memory allocation, you can actually, once you use a variable, once you know that its lifetime is over, I don't need this variable anymore, you can just free that space which is occupied by that variable. Okay, so in dynamic memory allocation, in the lectures that has been covered, we have seen malloc function, calloc function, realloc function, and free, the free function. So all these four functions are different ways of dynamic memory allocation in C. And all of this, what they do is they return to you. Okay, this three of this returns to you a pointer of type void. This is very important, that it returns a pointer of type void pointing to the first byte of the space allocated. Okay, so say here I have written int star ptr is equal to, I'll talk about this later, malloc 5 into size of int. So say size of int is 4 bytes. So I'll just assume that one int is 4 bytes in this particular system. It's a 32-bit system. So a size of int will be 4 bytes and 5 into 4 is 20. So malloc of 20 bytes. I'm basically saying that allocate me 20 bytes of space in the RAM during runtime. So what it will do, it will take in the RAM some 20 bytes of space it will take, and say you have all these bytes, all these boxes represent 1 byte. So here it will return you a pointer which is pointing to this particular the first byte of this entire contiguous space. Now keep in mind that it will return a pointer of type void, and you have to typecast that into whatever kind of pointer you want. So here I wanted to store int variables or int data into this particular contiguous memory that I wanted. So I had to typecast this. I typecast the void pointer to a int pointer. Okay. So it returned, this entire part returned to me this malloc of 5 into size of int. This returned to me a void pointer, a pointer of void type, and I typecast that into a pointer of type int. Okay. Alright, so what are we doing here? After that, we are doing a for loop where we are saving some values to this particular memory location that has been allocated to us, and we are printing a few things depending on increment and decrement operators. So can you tell me what should be the answer of this particular question? So what exactly will be printed from all of these printf statements? Okay, keep this in mind. I'll tell you, if you remember the operator precedence from earlier, maybe I'll just refresh your memory once. So operator precedence goes like this. Your pre as well as post increment operators are of higher precedence than pointer operators. Okay, so the precedence goes like this. So your pre and post decrement and increment operators are of a higher priority than star operators, and keeping this in mind, again go through it. Okay. Okay. So let's see this one by one. So what exactly is being stored here? So star in braces PTR plus I equal to I. Okay, so what happens when I is equal to 0? It's basically I'm saying star PTR is equal to I, right? And I is 0. So star PTR means it is the first element, or rather now I'll talk of it. So it is 20 bytes, and we change it to an integer type pointer. So I'll talk that that basically means that it can store 5 integers. So the first integer of this memory will be 0, right? Then what about the next one? So I've said that star of in braces PTR plus 1 equal to 1. So the next integer will be 1, and similarly it will go till 4. So 1, 2, 3, 4. So that is how you will have 5 integers saved. So your integers basically are 0, 1, 2, 3, 4. Okay, so this is the memory. These are the values that you have stored into the memory using this for loop. Now first in the first printf statement, what you're doing is star ptr plus plus. Okay, so this is a post increment operation, as you can see. So in post increment, if you remember, what happens is first whatever operation we are doing that happens, and then the increment happens. So the first the star ptr part will be executed. So the printing will occur with star ptr, and then the ptr value will increase by 1. That is, the index will increase by 1. So currently it is still pointing to 0. Okay, and it will, when you print percentage d star ptr plus plus, because of this post increment operation, first star ptr will be printed. So what will be printed? 0 will be printed, right? Because that is the element it's pointing to. So star ptr is 0, 0 will be printed. So we have 0 here. Okay. Okay, fine. Let's continue. Was I, was there any disturbance or something? Maybe. Okay, so from which place were you not able to get it? Okay, so this, the way that the saving part is fine, like that is what I had covered, or okay, okay. So that was visible to you, right? Like it was visible to everyone, right? The this for part when I explained. Okay, fine. So so when we write this star ptr plus plus, because this is a post increment operation, the star ptr part will be executed for the printf statement. So star ptr is basically 0 because ptr is currently pointing to 0. So 0 will be printed as the first output, and then ptr will increase by 1. So we printed 0, we increased ptr by 1. So ptr will become ptr plus 1. That means instead of pointing to 0, it will now point to 1. Okay, it will now point to 1. We are increasing the value of ptr by 1. That means instead of pointing to 0, now it will point to 1, because that is the next contiguous location that we have. So it will just shift it by 4 bytes in this memory space. It will shift it by 4 bytes. So now we are pointing to 1. Okay, so what happens next? We give star ptr but in braces, and then plus plus. So here again we are doing post increment operation, but this star ptr is in braces, as you can see. So what does this do? Braces have higher priority, so that basically means whatever is inside, that is the that is going to be executed first. So the star PTR, the value of star PTR will be what will be printed here, and then we will have our post increment. Okay. So star PTR, okay, what is star PTR currently? So it is 1, right? Because PTR, as I said, it was increased by 1, so it is now pointing to 1. That is that is the second element, you can say, if it is an array. So star PTR, basically when you print, it will give you 1 as the output, and then plus plus. Here, because there was no braces here, the value of PTR increased by 1. But here, because there are braces, the value of star PTR will increase by 1. So star PTR is equal to star PTR plus 1. So when you are saying star PTR, that means the value. You are talking about the value that is saved in PTR. So this value now becomes 2. So now our array or our memory space basically contains this information, and PTR is still pointing here, just that the value of this got increased by 1 and it became 2. Okay, so this is what happens after this step. Okay, now next step we simply just print star PTR, that is it is pointing currently to this, which has the value of 2 now, so we'll get 2 here from this step. Then what we do is star plus plus PTR, that's what we want to print. Okay, so this is a pre-increment operation, as you can see here, and I have said that pre and post increment operations have a higher operator precedence than star operation, which is the referencing or dereferencing operation. Okay, now so we'll first increase PTR by 1, right, because no braces here, nothing. So we'll increase PTR by 1, it will now point to the third contiguous element instead of this. Instead of this, it will point to the next integer that is being stored in the space. It will move by 4 bytes again. Okay, so but you can see it is still we have a 2 in this space as well. So star PTR, whenever you write star PTR, so it increases PTR by 1. It goes to the pointing the next element that is being stored in this memory space, and then star PTR will give you 2 again, right? Because this also has a value of 2 here. So star PTR is 2, right? Okay, so then next what we have plus plus star PTR. So it doesn't matter whether it's plus plus star PTR or star plus plus PTR, whatever the case. Plus plus operator, that is a pre-increment operator, has a higher priority or higher precedence over star operator, right? So again our PTR will be added up, it will point to this instead of this, and uh, star PTR will give you a value of 3, right? So it will be 0 1 2 2 3. So this is going to be your answer in that case. Is it clear? Okay, so memory allocation as in like what exactly happens when we write this malloc function and calloc function and those things? Or okay, all right. So, fine. So there are different ways of writing this. So everything has its own syntax, as you can see. So malloc basically, you need to write the number of bytes of space you need. Okay, and this will give you a pointer of type void. Okay, the pointer that will be returned from a malloc function will be of void type. So you need to typecast that into some type of. So I'm just writing type percentage, so that you have to typecast it into whatever type of variable or whatever type of data you want to store in this bytes you want, and that we will store to some pointer. As you can see here, we are using an integer pointer, so we are using an integer typecasting. This is an explicit typecasting. As you can see, we are forcibly converting it from a void type to integer type. Okay. So this is how you define a malloc. If the number of space on the number of bytes of space that you have specified that is not available in the memory, so it will simply return you a pointer of type null. Okay, so the pointer basically it will give you a pointer of type null, That means it was not able to allocate the space allocation failed. Okay, so that is malloc. And initially, okay, another thing about malloc is that whenever, say I define, okay, I wanted a allocation of 20 bytes of space here, and I converted it to an integer pointer. So all of this 20 bytes had some kind of garbage values in them. So initially it will have garbage values in uh, in all of these bytes. There are garbage values initially when I call for malloc. Okay, but the same is not true for calloc. So when you call for calloc function, it is a bit different. So here you need to mention the number of okay, the number of elements that you want and the size of each element. Okay, so this is a bit more refined than malloc. So in calloc function, what you do is you give two parameters as input. First is the number of elements and then the size of elements. So basically it's kind of an array that you are saying that I need, say I need 5 elements. So if I had to write the same thing in calloc, I would write calloc 5 comma uh, size of int. Okay, so the time, what exactly did you, okay, I couldn't get that. Typecast, I think for calloc function, I don't think you need a typecast. Let me just verify that. But I think you don't need a typecast for calloc because it you already, no, sorry, you need that. Sorry, you need that. Yeah, because finally it will return to you a void type, even though, see, you are specifying the number of elements and the size of each element, but you can absolutely give here 4 bytes instead of size of int or something. So you have to specify what kind of variable, like you have to make it a pointer of that type, whatever variable you want to, whatever kind of values you want to store. So typecasting is required in calloc as well. Yes. Okay. Yeah. So this is how calloc will work. And if you are working with integer variables particularly, then calloc will set everything to 0 initially. Okay, initially it will set the values, all the values to 0 if you are using integers. Here, here in malloc it would have been set to garbage values, but in calloc it will set it to integers. It is similar to like you're defining a int array, so it will give you zeros initially. So it is similar in that respect that calloc will set it to 0 or if it is an integer, it is an integer memory space. It's a memory space you are being, and that is being used for integers. Okay. Then we have the realloc function. Okay, so we covered malloc and calloc. So let's talk about realloc now. Now you already have this PTR. Okay, you have 20 bytes of space which has been allocated to this pointer which is PTR, and I want to like change it. I want to change the amount of space allocated to this pointer. So what I can do is I'll write realloc, then PTR, and the new size. Okay, say I had 20 bytes of space here. Now I can write that star PTR is equal to realloc PTR, comma, say I would say 10 into size of int. So what it will do is it will allocate 10 bytes of space. First it will try to expand whatever, wherever this exact memory location, contiguous group of memory locations is, it will try to expand there 10 to 10 size of int. If it's not available, it will allocate a new space to you. And if even that is not available, the space is not available, it will return to you a null pointer like it did in malloc. So realloc is kind of ideally you shouldn't be using it because you don't know if there is memory available in the previous location that is being given to you, if the memory is available. So it's always safer to just allocate a bit higher than you need, so that yeah, you can, even if it has some extra space, you can, if required, you can expand it within that itself. You don't need to use realloc. Okay. Then the fourth one is free. Okay, free is pretty simple. You just write free in braces PTR. Okay, so basically what this does, if you have no further use of this memory location, I'll just write free of PTR, free in braces PTR. That will free this entire memory location, and I can use it for other variables or something else. Okay, some other program can use it. So I'll just free this memory location in the middle of the code. Okay, so during running it will free the memory location. So in static memory location, what used to happen is till the end of that function you used to have and the variables that you define, those variables used to have their memory allocated to them, at least till the functions got over. And if it was a static variable, the variable would the space would stay till the end of the entire running of the entire code. So that is not memory efficient. So if you want memory efficiency, you can use dynamic memory allocation. Here you can free the space that has been allocated to you earlier, so that you can use it for other purposes. Now the disadvantage of dynamic memory allocation is speed. So our primary disadvantage here is speed. So because all of this memory allocation has to occur at runtime, so the number of overheads that is required between the execution and the memory access, that will cause you a reduction in speed. While if you had pre-allocated the memory, say in compile time, you don't even have to worry about the memory allocation part anymore. So the major disadvantage of dynamic memory allocation is the speed reduces compared to static memory allocation. Okay, but you have a few other advantages that you get. So it's basically a trade-off that you do here. Okay. Okay, so I think this is all about dynamic memory allocation that I had to cover. So is that clear to everyone, or is there any other doubts here? Uh, okay, that is quite difficult to answer. It depends on the code actually. Like what exactly, how many times are you allocating memory? The more number of times you try to allocate memory, um, the difference will be more clear, because it has to access the memory again. It has to so the memory it is a pretty complex process actually. I'll not explain it here how the memory allocation exactly occurs. So it's a that takes some time. So the more number of times you will allocate memory, um, the slower your code will be compared to if you had defined the variables in a static manner. The memory you had allocated in a static manner, compared to that it will be slower. So it's not, I cannot quantitatively say that this will be the percentage decrease in the speed, but it will depend on how many times you are allocating in runtime. Okay. Yeah. So any other questions? Okay, so let me go back to this question now. Okay, about structures. So here we have structure of type structure, which is P, and it has two member functions, int x char y. Okay, so one integer, and so it has one integer and one character. Okay, now I'm defining an array of this type structure P, struct P. Like I said, the way I can define arrays here. So it is I have just written 1 comma 21 69 42 64. Okay, and I am also defining a pointer of type struct P, and I'm setting it to P1. Okay, and I'm defining this I'm declaring this variable x, which is calculating the size of P1 and dividing it by 4, and we are doing some kind of comparison here and printing true or false based on that. So what exactly happens here? So what happens when we first make this or initialize this structure in this manner as it has been shown here? So like I said, the member functions, the way in which the member function has been defined is quite important. Okay, so the function that the sorry the not member functions, or rather members have been defined. The way in which it has been defined, the which comes after the other, that will matter. So first we have defined here the int member function, which is the integer, and then the character member. First the integer member, then the character member. Okay, so that is the way that we have defined this. So the first, the third, and the fifth, this will go to integers. So we are basically saying these are of type integer, that is int. Now the second, the fourth will be character. Okay, because it's alternating, right? First is, and the first member is integer, so this will be basically 1. So our, let's say, what is p1 of 0? P1 of 0 is basically 1, which is integer 1. Okay, let me write it in this manner. P1 of 0 dot x will be 1. P1 of 1 dot P1 of 0 of x of y, which is a character now, will be 21, right? So what exactly will it be in 21? So we'll just convert it to char. Okay, that is 21 is the ASCII equivalent. So so whatever the ASCII equivalent character of 21 is, that will be stored in y, p1 of 0 dot y. P1 of 1 dot x will be 69. P1 of 1 dot y will be char of 42, right? So that is the next character that you have defined. So what will happen with P1 of 2 dot x? That will be 64. We have mentioned that, but we have not really mentioned what will be the character value of P1 of 2 dot y, right? So what exactly happens here? It simply takes a value of 0, because we have not given anything here, we have not declared that. It will simply take a value of 0. So it will be char of 0. Whatever the char of 0 is, that is what will be stored in p1 of 2 dot y. Okay. Okay, I hope that's clear how we are defining, or rather declaring, this array of structure. All right. So when we define ptr1, which is a pointer to a structure or struct p, and we set it to p1, it points to the first element, like it happens with normal arrays as well. It points to the first structure that has been defined, that is this. So we could write ptr1 star ptr1 dot x, and that would give us 1. Okay, so so that is what would be. And when we calculate the size of P1, however, okay, how much should be the size of P1? So we have an integer, we have a character, say it is a 32-bit system. We have one int is equal to 4 bytes. Okay, so what exactly would be the total memory space allocated to a structure? 5 bytes, right? Because character is 1 byte, integer is 1 byte, 4 bytes, so total of 5 bytes. But when we define a uh, array of structures here, and it has how many elements? 3 elements, because it has 3 structures within it. So ideally it should be 5 into 3, 15 bytes, right? That should be the value of size of p1. So if we write size of p1, it should be 15, right? 15 bytes. Am I right or am I wrong? But it will not be 15 bytes. Instead, it will be how much? 24 bytes. It will be 24 bytes instead of 15 bytes. So yeah, that's how. Okay, okay, I'll come to that. So once this is 24 bytes, I'll explain it clearly in another page maybe. So once it because it's 24 bytes, 24 by 4 will be 6. and that is basically equal to size of int, which is 4, twice of size of char, which is 2. So added up, 4 plus 2 6. So x is equal to 6, which is true. So here true will be the answer. I'll just explain why it became 24 bytes instead of 15. Okay, so what we had here earlier was a structure of 3 bytes. Let me draw this structure for you in the memory. Okay, so we have one int and one char. Okay, like this we have three structures. Okay, remember that int comes first and then char comes. Okay, so let me just start from here. So I'll say this first 4 bytes are occupied by int. So we are starting at say 2000, 1000, and till 1004 we have an int. Then okay, then here in this, let me write it in this manner. This is one int. This is one char. Okay, so this is how it is stored. Then the next one, so this is 1005, 6, 7, 8. So 1008 starts from here. So we have 3, 4, it goes to 1012. So the next int will be stored here. Next character will be stored here. Then somewhere in 1016 will our next int will start. So this will be our next int, which will go till 1020. 1021 will have char, and then this will be 1024. Okay, so now what happens here? Do you see what happens? This 3, here you have 3, here you have 3. So this 3 bytes are wasted. Each of these 3 bytes are wasted. So here you waste 3 bytes, here you waste 3 bytes, and so on. Why is that? So what happens is, I'm talking about a 32-bit machine. Okay, so a processor in a 32-bit machine, it can read one word at a time, or rather I would say 4 bytes at a time. Okay, a 32-bit machine reads 4 bytes at a time. Okay, now whenever it reads 4 bytes at a time, it can read the first integer, and say it will be able to, let me again make this in the way that it should have been according to intuition. So this had been an int, this had been a char, and let's say the new int started from here. Okay, so I say 1005, and it would have, the new integer would have been from 1005 to, sorry, did I do it wrong? Okay, this would be 1009, right, instead of this. So the next integer could have been from 1005 to 1009, right? But what will happen in this case? Let's see. So first it will read this. This is the first 4 bytes. It will get an integer from here. It got an integer. Now for reading the char, say I want to read the next, the first element character value that is being stored. I'll read from how much? 1004 to 1008. So I'll read this entire part, this one. So what do I find here? So I find a character here. That is fine. I read that, I got a character. It's okay with me. Now what happens when I try to read the second element's integer? What will happen then? It will start from here, 1005. It will try to read. No, it won't. It won't read from 1005 to 1009. It has to read in 4 bytes at a time, and that will be from 1000 to 1004, 1004 to 1008, 1008 to 1012, in that manner. So it will have to read in the first cycle. It will read from 1004 to 1008. In second cycle, it has to read from 1008 to 1012. Now it will take 3 bytes from here and 1 byte from here, the first byte from here, because it is stored, if it is stored from 1005 to 1009, So it has to take this byte and this byte from here, and from another, it has to again go through 1008 to 1012, which will be another byte. It will take the first byte from there, and then it will get an integer from here, right? So you need to access the second integer element. You needed two cycles of CPU processing, basically. You needed two cycles of CPU processing to access the second integer, which is wasteful. We always try to reduce the number of cycles of CPU processing, no matter what. Even if we have to sacrifice a few memory locations for that, we always try to reduce the number of CPU processing as possible, as much as possible. So in order to do that, what the programmers devised is that let us have a padding of 3 bytes here and start the next integer from 1008. So when you say what is the size of P1, it takes this padding as well, because nothing else can be stored in this padding, because it is not possible to access it properly even if stored. So it will take the entire value of the padding, and that is how you can see that here it occupies 24 bytes instead of 15. So if this padding is present in when we want to access the value of the character of the first element, then it will read from 1004 to 1008. It will find a character in 1004, all the 3 bytes blank, so it will read the character. Next, if it wants to read the integer of the second element, it will read from 1008 to 1012, and it will get the integer in a single cycle. Instead of going through two cycles, in a single cycle it will be able to read the integer. So once we do the structure padding, we are able to reduce the number of CPU cycles required. Okay, so that was actually the objective of structure padding. So this entire thing is called structure padding. And when will it be present? It will be present when we have dissimilar data types, dissimilar I can say members of a structure. Okay, so if we have a structure which is having dissimilar members, like here in this case one int, one character, then in that case we will have this padding. Okay, is that clear why exactly the structure padding occurs, and why is it necessary to do structure padding? Yeah, to reduce the number of CPU cycles, right? So the entire objective is to reduce CPU cycles for memory access. Now if you want to reduce the memory as well, if you are saying that by this we are wasting memory, basically if you have a large array of structures, you'll be wasting a lot of memory just by padding. So in that case we can simply go and use a union instead of a structure. If our code allows for it, we can use a union instead of a structure, which will take the size of the largest member. Okay, so size of the union will always be the size of the largest member of the union. So we can use that data type if we don't need to store multiple members at the same time. Say I had a int and a character, so this union, if I define this as a union, you will have a total size of the union as 4 bytes. Now I can store one character in that 4 bytes. I can also store one integer in that 4 bytes, but whichever one, I can store only one at a time. If I if I have saved the integer now, I cannot access the character anymore, because the character will be deleted. Only the integer will be saved. Then if I want to use, I have saved the character, I want to access the integer, that is also not possible. So at a time, if you want to use only one member, then you can use a union instead of using a structure. Okay. Okay, so I guess someone had a question or something. Okay, fine. I hope this is clear to you, this particular exercise, why this structure padding occurred and how you could use a union. So let me also write this down. So while union is the size of a union, okay, the size of a union is equal to the size of its largest member. The size of a structure uh, can be, okay, let me, can be greater than equal to the sum of size, size of its members. Okay, both of these are important to remember. The size of the union is equal to the size of its largest member, while the size of a structure can be greater than or equal to the size of the sum of size of its members. Equal to when we have similar kind of members, so we don't need a so we don't need this kind of padding or anything. Or if you have dissimilar members, then it can be greater also because of all the padding that we'll have in the in between the um, in the structure itself. So because of that, you will have the size of the structure will be larger than the sum of the size of its members. Okay. Okay. So that is all from my side today. So I hope this has been helpful. These tutorial sessions have been helpful to you in um, answering the assignment questions, as well as it will be helpful to you for the final exams. So if you have any doubts, you can just ask me now. Okay, okay, fine. So that was everything for today. Thank you all for joining. Um, so I'll close the meeting now.